Welcome to today's topic. Today we're going to discuss the Appgate demo environment overview and the Appgate SDP architecture. So let's get into it. Here at Appgate, I've got a very big, very complex demo environment established that crosses boundaries into AWS, Azure, GCP, and even a physical data center in Gothenburg, Sweden. You can see all these various environments represented in this rather complex PowerPoint diagram. User in the center. I've got some connectivity to various identity and access management systems. I've got some third-party integrations as well with this demo environment. But every demo that I give to every customer and prospect, and even strategic partners, is all based on this environment. Its complexity exists simply because of the breadth and depth of features that we're able to show with Appgate, but don't let it overwhelm you. So let's advance the slides a little bit, and I'll get into some simplistic ways to describe exactly how Appgate works. So the first thing to think about is there are Appgate appliances on the edges of the networks of all the data centers where I have applications deployed. These appliances are represented in my diagram with various graphics. The cog graphic represents a controller. So remember, the controller is an authentication and authorization mechanism. From the software-defined perimeter specification, you might know of it as a policy decision point, or a PDP. Notice I have multiple in my environment. I'll explain that in a second. The second graphic on the screen to think about is the gateway graphic. Also, multiples in each data center, right? So you never want to have a single point of failure in the Appgate deployment, and this is where we can achieve this redundancy within the data center level for the gateways themselves. And the gateways are the policy enforcement point, or the PEP, right? From a software-defined perimeter specification perspective. These are two of the most important functions, but by no means all the functions within the world, within the Appgate world. There are other functions, including the connector function, the log server function, the log forwarder function, as well as the clientless portal function. And I'll expose those in other ways in upcoming demos. The next thing to think about is that each of these appliances sitting on the edge of the network do have public IP addresses, but those public IP addresses are not accessible by just any outsider. They are only accessible to authorized users through something that we call single packet authorization. Single packet authorization prevents the unauthorized access of anyone in the outside world from reaching your Appgate appliances. This is an important aspect of bringing additional security to the Appgate appliances. As an end user, I'm going to point my client to a DNS name, and that DNS name is going to work its magic. This has nothing to do with Appgate, to decide which controller to allow me to communicate with. That DNS, in my case, Route 53, is going to use geography-based routing to decide where I am and where the closest controller is to my current location and route me to that destination. These controllers run in a hot scenario. I have 3 in my environment. Today we support up to 6 of these controllers in anyone's environment. Once I get connected to a controller, of course, that single packet authorization key will be exchanged, allowing me to communicate with that controller. I'll provide credentials to the identity provider I choose. We support any OIDC, SAML, LDAP, or radius-based identity providers. No federation here, no downloading of user databases. We actually make real-time calls to that service and validate the user credentials that they've provided. At this point, the controller then pulls back information from that identity provider about the user. So the controller now knows any groups, any custom attributes, anything that identity provider knows about the user. Appgate is able to take advantage of that information and use it to build policies. And depending on how your Appgate environment is set up, you may at this point reach out to other third-party systems that you've already invested in, say ServiceNow, Illumio, CrowdStrike, Menlo. These are all other systems that may contain important and useful information about your user or the world that they're coming from to determine whether or not they're trustworthy. The controller also has the ability to reach into the device itself that the user is using and the network that that device is connected to, again, pulling information into Appgate and making it available to the policy engine. Once that info is bounced against the policy engine, you will qualify for certain entitlements. Those entitlements will live in certain data centers. We call those sites, and those sites are protected by gateways. Your Appgate client is told about these entitlements and which sites they live in. It will reach out to the gateways in those sites and attempt to communicate with them, first by exchanging the SPA token and then establishing a secure encrypted tunnel between the end user device and the gateway itself. Multi-tunneling is a critical aspect here. There's no single tunnel going into one data center and then leveraging back-end connectivity between data centers. So notice my end user in the diagram has 6 different tunnels going to 6 data centers all over the world, connecting him to those particular applications or those particular data centers that he needs access to. And then finally, the Appgate client on the end user device will then serve up the firewall rules that define exactly which applications and how that user accesses those applications will be served up to those gateways. These firewall rules are embedded in the gateway for the user, they're private to that user, and they're ephemeral. If the user logs out, disconnects from that appliance, those gateway rules will go away and they'll no longer exist in the appliance itself. And so that's how we can limit exactly what the user can do within that data center once the user is authorized and allowed to access applications.